Dear Sapdalf, could you tell me what are the most powerful spells in the world?
Yes, of course, those are Linux commands.
Oh, I heard about that. The most powerful spells in the enchanted grimoire of the digital cosmos are none other than the sacred incantations of Linux commands.
Yes, the same ones I'm talking about.
Could you please give me some powerful Linux commands? I'm asking for a friend.
Sure, why not? Let me tell you about some of them. I think you'll like them, regardless of whether you're just starting out with Linux spells or already know a bit more. I'll try my best to make sure that something can surprise every magic enthusiast. But use them wisely. I have to start with that one. Forgive me, but I must. A powerful spell of knowledge dispelling the darkness of ignorance and unnecessary questions on forums. And an interface to the system reference manuals. This is the official definition, but what is it for? This utility allows you to see how a command can be used. Usually, in addition to the syntax definition, it also contains a full description, examples of use, options divided into logical sections, return codes, or involved files. Scrolling up and down through the document is, of course, fully available, as well as searching. A kind of quick alternative or addition is the what is command. It shows a very brief description of the given command. In addition, it allows you to determine which sections of the documentation are available to man. See, for example, what documentation is available for passwd. Section 5 describes etc passwd file. The command to change the password is available in Section 1. And additionally, we have passwd as a command in the OpenSSL command list. Well, I realize that convincing a new generation of administrators to look into documentation is as abstract as saying them to visit the Library of Alexandria to do so, or play music from vinyl in the age of Spotify. But I encourage you to use the man command whenever you need to. Quickly see what the options are or examples of how to use a command. It's much faster than Googling. Let's continue with something really simple but very useful. Tail for a Linux administrator is as important as for a snake. Although the snake all looks like a tail, Linux administrator does not. I prepared a text file with 15 lines to make the presentation easier. Tail shows the end of the file. The default is 10 lines. But we can change it to any number, for example 7. And it's not even that it's a magic number, it's just a number. Boring? Maybe so, but there is an option that makes Tail the king of analyzing current log files. A weapon worthy of a hunter. This is the follow option, abbreviated to F. It allows you to keep track of the file and new data appearing in it. Line by line, quietly looking out for the information you are seeking. Like a predator lurking for prey. To set up a demonstration of how following by tail works, let me quickly write a command that adds the current time to some file every 2 seconds. Then, later, we'll trace it using tail follow. The lines appear at regular intervals. In the same way, you can view any text logs. Let me run the script to start generating new entries to several logs. Tail can follow more files simultaneously. This is useful in many situations. This way you can check appearing entries in all SAP work processes logs, which is extremely useful. As you could notice in our example, you can see not only the new entries, but also information in which log file they appeared. The opposite of the tail is the head, especially in case of a snake. But let's maybe just check how to display the first 5 lines on our file. Or maybe 3. Or something more interesting, the next to last 2, that is, the first 2 of the last 3. And that, in addition to the -F option, is the most commonly used combination. Whenever we have the result of some command, and we need to retrieve through the script the nth line from the beginning or the end, we use the head and tail combination. This is very useful, Let's deal with something a little more interesting now so that more experienced viewers will not be bored to death. A command that can bring clients and servers to life. Allows the exchange of thoughts and data over a distance. Simple and reliable. The quintessence of Linux. The tool has very rich features and allows you to set up and test TCP/IP connections, but also UDP or Unix domain sockets. I will show some tricks related to TCP. I will need 2 computers for this. So in the right window, I'm connecting via SSH to my N100 server. I connected via SSH, which runs on port 22. So I know that this port is open on the N100 side. Let's see if netcat confirms this. I use the -Z option because I'm just testing the connection and don't want to send data. The -V option means verbose to get a descriptive result. Next is the host name and port number. As you can see, the port is open and the connection is possible. So we have the first important use of NC, checking if a port is available on the other side. For this to happen, the service must be active, and no firewall along the way can block traffic. In contrast, I don't expect anything to listen on port 1234. But let's check. As expected, connection refused. Could netcat also help us to activate the service? Of course. The L option can be used for this in combination with P and the port number. L is listen, obviously. Let's now check from the other side if the port is really open, and yes, it is. Netcat instance finished after receiving connection, so I will start this up again. Now I can show that with a simple telnet command, I'm able to send messages. Netcat displays the data after sending the entire line. And it obviously goes both ways. It's magic, isn't it? You can also prepare information to be sent by the server in advance. As for the client, we can send something by redirecting through the pipe the echo command. As you can see, the typed text appears on opposite sides of the connection. Where else can this be used? Imagine that you are installing an SAP server. You ask in advance to open ports on the firewall. You need to confirm if the connection is possible, and you don't have the service installed yet. So you open the port with simple NC command and test. You know what the network situation will be once you have installed the SAP server completely. It is quite common case, isn't it? Let's talk about making backups to tape. No one makes them to such a medium anymore. Well, then maybe you didn't know that tar comes from tape archive. I know. Now it's just an archiving utility. But tar still does the same thing it used to do. It glues files together into a single sequence. So we can make one archive out of many files. Yes, one tar to rule them all, one tar to find them, one tar to bring them all and in the darkness bind them. Here are the most useful options for the tar command. Let's check my files directory. I prepared some files in 2 folders. One file is not owned by Sapdalf. Now I'll create an archive. C is for create. V is like verbose to see a list of processed files. F is followed by file name of the archive. Then asterisk specifies that all files should be included into the archive. It's done. 2 folders and 4 files have been included into the tar file. I'm creating a new folder to untar the archive here. I can now extract the files. X is for extract, V is still verbose, and F specifies tar file. It's done. The same folders and files. The only difference is that all files are owned by Sapdalf. Why? If the archive is unpacked by a regular user, tar does not try to preserve file ownership by default. It is different in the case of root. I'm switching to root to present this. I'm changing current directory to Sapdalf home subfolder and use exactly the same command to extract files. Now I can log out from root and check the result. Ownership is preserved. That is why before upgrading the SAP kernel, we usually back it up via tar using SAP-ADM. On the other hand, restore is always done from the root account. Let's modify our command to create the archive. I'm adding Z to zip the archive. Now this is tarball, like a fireball, but with tar. It's why I added GZ to the name. What is the real difference? Yes, the GZ file is significantly smaller, keeping the same content. What a magic. I'll do one experiment. Instead, using file name, I'll add dash, which means standard output. Then I can redirect the result to file. The result and file size is exactly the same. Thanks to this test, I can do one more experiment. Let me log into another machine. I'm using well-known netcat to start listening on TCP port 1234 and redirect output to tar, which expect input from dash, so standard input. Now, on the source machine, I can send tar output by using dash to netcat, which sends stream to N100 computer over port 1234. And magic. Archived on one side and extracted on the other. I must admit that this is just an experiment or a last resort option. In normal life, we usually use SSH and encrypted transmission in such cases. LN or everything about links and relationships in the file world. I have prepared a file for our experiments. It has some content to distinguish it from other files. I can check technical information about this file at the file system level. Here you can find the inode number, which is a kind of logical location on the disk. In simple words, which node this file is assigned to. You can also find information that this file has only one link. What does it mean? Let's create a symbolic link with ln command. As you can see, test2 points to test1. I can check content of test2 and it is the same like test1. But test1 has still one link only. Let's check test2. This is assigned to different inode, so both are separate entities. Consequently, the symbolic link is just a pointer. I can rename my test1 file. But it breaks existing link. I can say, that symbolic link is not so sophisticated. I'm renaming the file back to fix the issue. But in fact, I don't need the link anymore. It's too boring. Let's move to something more exciting. Test1 only. Let's create standard, not symbolic link. Interesting, it doesn't look like link, does it? Let's check details. Wow, now test1 has 2 links. What about test2? Also 2 links. What's more, the inode number is the same. So we have 2 files in one place. It's like two-headed dragon. Let's create the third head. Yes, 1 file in 3 instances. Let's add something to test2. Let's check content of test3. Yes, it contains changes. What about test1? The same. This is 1 file under 3 names, so I'm removing one of them. Test1, the source one. Will it affect the rest? No, because this is not a symbolic link, but a hard link. The only difference is that we see 2 links in stat. I'm removing one more to have only one. Unlink is like RM. Now there is only 1 file. Let's do one more experiment to learn something about Linux file systems. I'm opening the file for reading by tail-f command. Now I'm removing the last file. Obviously, it doesn't exist anymore. but process 72222 still reads this. Let's go to special file system named proc, to folder with process number to see FD, like file descriptors. Number 3 is our deleted file. Yes, we can check its content. Let's copy this quickly to TMP. Now I'm terminating the tail process. Due to that file doesn't exist anymore, but I copied this safely to TMP. Consequently, I can recover it to my original location. Our souls are saved. File has been successfully recovered. Now you're probably convinced that by stat and the number of links you can verify that this is the only copy of the file. Is that so? Let me show you one more trick. I'm doing a virtual mount of one folder into another with mount bind command. In new files directory, I see one file. I can stat is to check number of links. Yes, there is only one link, so this is original file. I'm adding text to my file to check if this is really true. Now I can mount the folder. Let's check what is in the original location. Was the file changed? Yes, it was. So you can't really trust in number of links, because there is more magic around. VI is an editor used by probably all wizards. It has amazing capabilities, although it is difficult to get used to. And hard to believe at first, it is very convenient. I prepared a list of the most useful commands. I'm copying the file because we'll edit it with VI. In fact, with VI improved, so Vim. It's not the same, but we can assume it is. I opened the file and removed something by mistake. The first lesson, how to exit VI without saving. :Q enter. But it doesn't work, because the file has been changed. So I need to force quit with exclamation mark. And we are out. Success. But come on, let's return and learn something more. Let's go to line 11 by :11 enter. Enter edit mode to append text and the end of current line by pressing uppercase A. Go back to command mode by pressing escape. Let's write changes by :W, enter. Written to disk. $$ moves us to the end of file. Let's search backward with question mark. Go there. Add line above and enter to edit mode by pressing uppercase O. I'm adding 2 lines and go back to command mode by pressing escape. Now I'm deleting 2 lines and placing them to buffer by pressing D2D, removed. Go to end of file by $. Paste the 2 lines from buffer by pressing P. Done. Save and quit by :W and Q. Saved. Vim is a modern editor. It can colorize code syntax. On some terminals, this is annoying, but you can disable this by :syntax off. Vim is a powerful editor. You don't even know how much. If you want to start learning, you can use the Vim tutor command for that. I recommend this not only for beginners. Well, the job market and AI is very hot topic. But this time, this is about Linux jobs. You know, tasks for programs. I prepared a script to print a new numbered line every second to present you something. I can run this script interactively and terminate it after some time with Control-C. Nothing special. But do you know Control-Z for suspending jobs? I can do this as well. Jobs command shows list of my jobs. One is stopped. I can resume this with foreground FG command and job number, and suspend it again, and resume again. And suspend? Why not? This time I can terminate this with kill command using %sign and job number instead of PID. One more experiment. I'm starting the command with redirection to a file. I'm suspending the job and checking what was recorded in the file. In the same time, in the second window, we can start following changes in the file with tail-F command. I'm checking the stop job, but this time instead of bringing it to foreground, I'm sending the job to background with BG. We see that job is running again, but I can work without any problem because it's in background. However, anytime I can get this back to foreground with FG, then I can even terminate the job with Control-C. I can see that it is not running. It can be confirmed with jobs command. AT is a command to run anything at a certain time, simple and clear. Better than cron for one-time executions. Let's schedule something at 1:10 a.m. Just anything. A list of files with redirection to another file. Control+D ends editing and schedules the job. Now something in 1 minute from now. A script with redirection to tmp test.txt. Now something more complex. Planning for execution in the distant future. 1:10 a.m., but November 11th. 2 commands in a row. Let's see what is scheduled on my user. ATQ, those are the jobs. I could remove something with ATRemove command. But what is a use case for SAP Basis Administrator? Let's imagine we use SID ADM user and want to schedule system stop on 1st of April. I'm switching to CSH shell. Then in my environment, I use SAP control command. For instance, 7.7 with stop function. Simple and functional. Let's see if our 1-minute command has been already executed. Yes, the file has been created. The network is something that connects fishermen, spies, and administrators. Netstat allows you to watch the connections in your network as long as you are an administrator, not fisherman. Let's start right away with practice. Netstat lists connections. L stands for listen because I want to see only the listening ports. N is for using numbers only, not names. T is for TCP because I'm not interested in UDP or Unix domain sockets. Those are ports which are open on my machine. You can see on the right that they are all in listening state. In the column Local Address, you can check which of them are listening on local interface only, and which on the real network. Those are with zeros. To demonstrate something, I will connect to my second computer. The latest Debian is installed on it. Let's see if the command will work the same there. Well, it doesn't work, because someone figured out that it's too old. What an ageism. Fortunately, we have a newer equivalent, SS, which works very similarly. LNT options looks almost the same. Let's check something different. I want to see all connections established from my first computer. I can list all TCP connections with A and T options, plus N for numbers instead of names. I'm using grep to filter IP address of my computer. As expected, there is one connection in established state to port 22, which is SSH. What if we drop the N option and filter the result by SSH? We will see this one established connection and 2 listening, the classic TCP and V6. To show you one more useful option, I'm starting NC for listening on port 2222. So we know what process is listening on that port. It is NC, whose PID is 30369. But sometimes the administrator does not know this. Netstat helps to check such things. You need root privileges to use the P option. The last column contains PID of the process listening on this port and the program name. This is very useful. tcpdump is even much better than Nilfgaardian spies. It is the king of intelligence. It allows following not only connections, but also individual network packets. Let's start this. Well, because it is so powerful, it requires special system privileges. It's why I'm using root for this demonstration. I'm starting tcpdump without any options on my second machine. A lot of data appears, so usually it doesn't make sense to start the command without any filtering. Fortunately, filtering is very advanced in these tools and allows us to be quite precise about what we are looking for. I'm confirming that no service is listening on port 1111. Even in such case, I can monitor if any packets are coming to this port. I'm filtering with destination port option. Let's check from the other machine if the port is listening. Netcat tries to initiate connection to this port and receives connection refused. But tcpdump recorded the incoming packet. We can see the source and destination, but what is most interesting is the flag. S stands for synchronization. This is the packet which initiates connection. If we see it, it means the counterpart is trying to set up a connection. But how does the client know that the connection is not possible and not wait for a timeout? Probably there was some kind of return communication and we filtered the data too much. Let's try, instead of looking for packets coming to port 1111, to select those that involve this port as a source or destination. I'm repeating the connection try with the same result. But this time tcpdump recorded 2 packets. One is known synchronization. But in addition, we can see packet traveling in opposite direction. The flag is R, which means reset. It immediately terminates the connection. It's why client reports that the connection is refused. Let's watch how it is for a valid connection. I'm starting listening on the port with the known netcat command. I'm confirming with netstat that we listen on this port. Now I'm starting tcpdump with known filtering and sending some data through the connection with netcat. Exactly 6 bytes of data. We see that many packages have been registered. The first is S, a familiar synchronization. The second is a new one, S with a dot. This is a synchronization acknowledgement. That is, saying the port is open, I am willing to talk. The third, which is a dot, is a return confirmation of receipt of the synchronization acknowledgement. But the dot can acknowledge receipt of any package. The important thing is that such a trio of packets is typical of any correct initiation of a TCP connection. And it is this trio that you will most often look for in the tcpdump logs. Then we have the P package, which pushes the data. See that the length is reported as 6, which is the length of our hello message. The last packet is a dot, which is an acknowledgement of the previous one. The connection is active all the time, until I close it via Control-C on the client side. In such case, we see finished packets on both sides with the final confirmation by dot, which gracefully ends the connection. And that's it. The tip of the iceberg, but at least something. The list of useful commands is certainly much longer. And what commands do you like and find helpful? Share them in the comments to this video. In any case, thanks for watching. If you liked it, give a thumbs up and consider subscribing to this channel. May your incantations and command sequences be stable and unyielding, ensuring the reliability of your mystical Linux spells. May the network winds be ever in your favor, carrying your data swiftly and securely across the realms, with minimal latency and maximum throughput. See you next time.